Hi y'all, welcome to week 8 of distance learning. This week's topic is going to be series. This is not review, this is a new topic. This is going to be a very helpful topic for those of you that are going to move on to calculus. Even if you go into something in your career that has to do with any kind of like computer programming or anything like that, you would definitely use series. If you're going to go into finance, you would use it. So a series is just the sum of the terms in a sequence. So I've drawn this kind of diagram here for you. In order to produce a series, it needs to have a sequence within it that you're adding together. So you're basically taking all of the numbers in a sequence and you're adding them up, and that's going to give you the series. The way that we write series is called sigma notation. So sigma notation. It kind of looks like a weird letter E. Don't freak out by this. It's just the way that we write it. But we're going to go over like breaking down each piece of it and what each piece means. So that fancy letter looking E thing that you see there, that is called a sigma, and it just means sum. So if you move into higher level math, you'll see a sigma symbol, and it means it wants you to add things together. The different pieces that we have something called an index. Index is just the number of times that I'm going to be adding up something total. So at the top where you see the letter N, that is the ending index value. That means that's the total number of times that I'm going to take this sequence and add those terms together. The index variable, so moving down here, that's just the letter that's in your sequence. So if my sequence was 2x plus 1, the index variable there would be x because it's the letter that's in my sequence. Most of the time with these, you're going to see the letter K. The beginning index value, that is the first term that you're going to start adding. So if K was equal to 1, that means that I'm going to start with term 1 in my sequence and then go up from there. If K was equal to 5, I would start with the 5th term in my sequence and add going to there and forget about the other terms that were previous to that one in the sequence. And then the letter F, that's just the name of the sequence that you're adding together. Okay, so let's take a look at an example. So our example, we've got the sigma notation here. I want to identify the index variable. So this is just a fancy way of asking what letter is in the function. So looking back here, in the parentheses, I have K plus 2. The letter that's in there is K. So my index variable is K. Next, what is the beginning index value? So this is the first number that I would be substituting for K if I were looking at it in terms of a series. So the beginning index value is whatever K is equal to. Since I have K is equal to 3, it means that 3 is my beginning index value. What is the index value? That would be the last number or the last term in the sequence that you would add. That is 12. It's the number that's like on top of the sigma symbol. What does sigma mean? It means that you are going to add, or you might also hear it referred to as summation. Remember that sum is the result of an addition problem in math, so summation would mean you're adding those terms. Lastly, you see, what does f of k mean? Do I multiply f and k together? That's not what it's saying. So no. It means that you have sequence the sequence is called f, and it has the variable k in it. Okay, so that is just kind of a mapping of these different things. So on the next page, let's actually map out what these things are. Same example. So the K equals 3. This is our beginning index value. And for now, we'll call it the start. The 12 that's up here, this is our ending index value. So we'll say end. The letter K that's here, this is our index variable. And then the entire thing in parentheses that we've got here, that whole expression, this is the sequence. Okay, so let's try some examples with this. So I've got my sigma notation here, and it wants me to evaluate that. This means that I'm going to be starting with the first term in the sequence. I'm going to add the first term, the second term, and stop at the third term because 3 is at the top of the sigma. And I'm going to add all those together, and that's my answer. So if I wanted to find, I'm going to start with k equals 1 because that's my starting index. So if k is equal to 1, that just means that I'm going to take my sequence here and I'm going to replace k with 1. So that would be 5 minus, I'm not going to write k, I'm going to write 1 instead, squared. 5 minus 1 is 4, squared is 16. Now I'm going to move to k is equal to 2. So I've got 5 minus 2 squared, which is 3 squared, which is 9. Then I'm going to move to 3. So I've got 5 minus 3 squared, which is 2 squared, which is 4. And I'm going to stop at 3. So just to kind of reiterate, the reason I'm starting at 1 is because of this. The reason I am stopping at 3 is because that's the number on the top. And then I'm just substituting k for whichever value of k I'm looking for in my sequence. So the sigma, that E shape, is now going to come in. You're going to take the 3 numbers in your sequence that you just found, and you are going to add them together. So I get a different color. These 3 numbers, I'm going to add those together because the sigma means sum. So I've got 16 plus 9 plus 4 is 29. So my answer, say the sum is equal to 29. So this means that if I take the first 3 terms of this sequence and I add them together, the number that I get is 29. Okay, let's try another example. So this one wants me to expand this as far as I can. Notice that the first example said evaluate. Evaluate means that my answer is going to be a number. If it says expand, that doesn't mean that my answer is going to be a number. It's just going to be a different representation of what's already there, but it's going to be longer than what's already there. I'm expanding it. So my starting number here is 1, and my ending number is n. I don't know what n is. It could go on forever and ever. It's just some number. So I'm just going to get the first maybe 3 terms for this and go from there. So if my k is equal to 1, that means that I'm going to have my sequence here, and I'm going to replace k with 1. So I've got 2 times 1 plus 1 squared. So that's 3 squared, which is 9. If k is equal to 2, I have 2 times 2 plus 1 squared, which is 5 squared, which is 25. If k is equal to 3, we have 49. And I could keep going on and on forever with this because my ending value is just a variable. It's not a number. So if k is equal to n, if k is equal to any other number that I want, I would have 2 replace k with n squared. So without the parentheses around the n, you would just have 2n plus 1, that whole thing squared. So the way that we're going to write this is the same thing as what we did before, except I can't evaluate this to a certain number. So the part that I highlighted in purple, I'm still going to add those together, but I'm not going to write it as a numeric answer. So I'm going to take 9 plus 25 plus 49 plus ... That means that there's just numbers in the middle, plus 2n plus 1 squared. So that 2n plus 1 squared, I could give you any value for n, and you would substitute that in and you would get a number. But we're not looking for that right now. We don't know n, so we're just going to write our answer like this, okay? The next question is a pre-AP extension. So for my regular kiddos, if you want to watch it, you're more than welcome to, but if not, you can just go ahead and jump to the next page. For my pre-AP kiddos, this extension piece here is going to require a little bit of algebra in it. So you'll see that you've got these numbers and you've got a negative sign in front of your summation. You can distribute that into your sequence. So I could distribute this 4 and I could distribute this negative sign. Think of it kind of like a coefficient. So that would turn this into the sum. This is going to be 20k minus 8. And then this is going to be, since I'm distributing that negative, all the signs are going to change. Okay, so what's special about this now is notice that your two summation pieces, those are both the same. A special property is that since they're both the same, you can actually combine the sequences that are inside of the parentheses and just write it as one summation. So you're going to take 20k minus 8 plus negative 3 plus 2k minus 4k squared. And then I'm just going to rewrite this and combine my like terms so it's in standard form. If I add 20k and 2k, I get 22k. And then negative 8 minus 3 gets me negative 11. So when I write this, I'm going to keep that sigma the same. And I'm going to go negative 4k squared plus 22k minus 11. And this would be my simplified summation. Okay, now let's look at arithmetic series. So last week you looked at arithmetic and geometric sequences. Now you're going to be looking at series. In order to create a series, you need a sequence. So we're going to do a little bit of solving here. There's two main equations that we're looking at. I think that this one is probably a little bit easier for y'all to grasp, so I'm going to stick with that one the whole time, but you could use either one. So Sn stands for the sum of a certain number of terms, and n is going to get replaced with some number. A sub 1 is the first term. A sub n is some term. They would have to give us n. And then n is the number of terms that are going to be added together. So this first example says to find S10. So using this formula, if I want to find S10, that just means that I'm going to replace all of my n's with 10s because that's the number of terms that are going to be added together. So S10, 10 divided by 2 is 5. Got A1 plus A10. So the pieces of information that I need to figure out this number are A1 and A10. It gave me A1, but it did not give me A10. So I've got A1 is 5 plus A10. To find A10, this is where you need your knowledge from last week's. This is kind of the spiraling in, that building of concepts you see all the time in math. To find A10, you're going to use, since this is an arithmetic series, you're going to use the equation for arithmetic sequences. You can look back at your notes from last week if you need to. Should be D. Okay. The pieces of information that I have. So they gave me A1, they said it was 5. They gave me D, they said it was -3. And N, since I'm looking for A10, it means that my value of N is 10. Okay? And then we're just going to simplify this. We get -22. So that means I'm going to be replacing A10 with -22. And if you do the math on that, you're going to get -85. So the value of S10 is -85. So that means if I were to take this sequence that has a first term of 5 and a difference of -3, and I were to add that together 10 times, then I would get -85. Next, we need to take a sequence that's already been given to us, and we need to write it in sigma notation. This part here, this should just be 3 dots, okay? So first thing I need to figure out, in order to have a series, I need to have the sequence first in order to write the sigma notation for that series. So let's try to figure out the equation for the sequence first. So between these terms, what's happening? Well, to go from -3 to 5, I need to add 8. To go from 5 to 13, I need to add 8. So since I'm adding, this would be arithmetic. The common difference is 8, and my first term, A1, is -3. So again, I'm going to use that arithmetic sequence equation, and I'm going to write the explicit formula like we did last week. I'm just going to replace A1 with -3, and I'm going to replace D with 8. And that is the sequence, the arithmetic sequence. Now, if I want to write the sigma notation for that, the pieces that I have, to start out, for right now, we're always going to start our index at 1. And the sequence that's going to go here, I just figured out the equation. I have -3 plus 8 times n minus 1. The piece of information that's missing here is the ending index. I don't know how many times that we're going to be adding this sequence together. I need to figure out what that is. So the question mark what's the total number of times that we're going to add this sequence? So it's just asking you to find the index. Okay, so the way we're going to do this is I know that the last term in the sequence is going to be 77. So that means that a sub n is equal to 77. So this was the equation for my sequence. I'm going to replace a sub n with 77. Everything else stays the same. And then now I've just got this and I need to solve for n. If I solve for n, that's going to give me the index. That's going to give me that red question mark that's at the top of the sigma. So I'm going to start by adding 3 to both sides. You are not going to do -3 plus 8 is 5 and then 5 times n minus 1. Don't do that. Add 3 instead. Then I'm going to divide both sides by 8. And then I'm going to add 1 to both sides. So I get n is equal to 11. So my question mark that was at the top, I know that it is in 11. So for my final answer, when I write my sigma notation, I'm going to start at 1. I'm going to end my index at 11. And then the sequence that I'm going to be adding is this. So what you just wrote says that you are going to take this sequence, you are going to add the first term, the second term, the third term, all the way up until the 11th term. You're going to add all those up, and that would be your answer to that sigma notation. Sorry to jump the video like that. I just realized I made a mistake here. This should not be a letter N. That should be the letter K. Because the letter at the bottom of your sigma notation is K, so the letter that's in your sequence should be K. Now let's look at geometric series. So this is very similar to what we just did. It's just a different equation. So in the first example, we want to find S6 given A1 and given R. And then the equation that we're going to be using is this one up here. So I'm going to rewrite the equation. I'm going to replace A1 and R, and I'm looking for S6, which means that the value of n is 6. So I've got S6 is equal to A1 is 8, R is -3/2, N is 6, and R is -3/2. Just gonna make that look better. There we go. Okay, so if you want to put that in your calculator, you would get -33.25. So that means that if I were to add the first 6 terms of that sequence together, that is the number that I would get. Okay. Now I'm going to write the sigma notation and find the sum of these numbers. So first, again, I need to build a series from a sequence. So let's try to figure out if the sequence is geometric or arithmetic. So going from 1 to 2, I can add 1 to get to 2. But if I go from 2 to 4, that rule doesn't work again. I can't do 2 plus 1 and it give me 4. So another option that I have is it looks like I'm doubling the number that's there each time. Doubling means that you would be multiplying by 2. So my first term is 1, and my common ratio is 2. So this is a geometric sequence because I have to multiply to get from one to the other. Remember, arithmetic means you add or subtract to get from one to the other. So our geometric sequence formula, you can look back at your notes from last week if you want to. This is what it looks like. The pieces that I have, I've got A1 and I've got R. So I've got A1 is 1, R is 2. I really don't need to write the 1 that's in front. It's not really doing anything for us. So that would be my equation for the geometric sequence that represents these numbers. So when I write my sigma notation, again, we're always going to be starting at 1. Back to this. Okay. So at the top, again, we don't know how many times we're going to be adding this together. And then on the inside, I'm going to have 2 raised to the k minus 1. I'm just swapping out n with k because if you, at the bottom, if you define it as k equals 1, and then you put the letter n in your sequence, it doesn't make sense. So just make sure you're keeping that number consistent throughout. Okay, I think on the key, I made that mistake as well, but just try to pay attention to that. So here, I'm going to be solving for that question mark again. So I'm still looking for how many times am I going to be adding this sequence or these terms together. So my last term in the sequence is 32. So that means that a sub n is equal to 32. So we've got a sub n equals 2 raised to the n minus 1. I'm going to replace a sub n with 32. Now think back to when you were solving for n when we had the geometric sequences. When you wanted to get that n minus 1 or you wanted to get that exponent brought down, you take the natural log of both sides. So I'm going to take the natural log of 32 and the natural log of 2 to the n minus 1. I'm going to use the power rule and I'm going to bring that n minus 1 to the front. So power rule is logs of logarithms. If you take calculus, you will be using it quite a bit. Okay, I want to get that n minus 1 by itself, so I'm going to divide both sides of the equation by the natural log of 2. Put that in your calculator, and you're going to get 5 equals n minus 1. Add 1 to both sides, and you get that n is equal to 6. So this was our question mark. So over here, I'm going to erase the question mark, and I know that I'm going to go to 6. So this means that I'm going to be taking this sequence, the 2 to the k minus 1, and I'm going to be adding the first 6 terms of that sequence together. The practice problems, again, they're not graded, so it's up to you if you want to do them or not. This is the first page of your practice. The last 2 problems are pre-AP extensions, so my regular kids, you can ignore those. The first page is just expanding out the series. So look at the notes section where we expanded out the series, and that's what you're going to do here. And then the second page, like the first page, where it's asking you to expand that out and then add up the first however many terms it wants you to. Page is writing sigma notation, and then you also have a pre-AP extension question there. If you see the letter K on your paper, it's not supposed to be a K. It's supposed to be a ... It's just a weird formatting thing that Word does. So you can just ignore that. The key to this is on Google Classroom, so you can go there to check your work if you want to. And again, if you only feel like doing a couple problems or 1 or 2, just however many to get acclimated with it, that's fine. It's not graded, so it's just for you. For your reflection questions, some of the things I want you to think about: what is the difference between a series and a sequence? So remember that in order to create a series, you need to have a sequence there because you're adding the terms of the sequence together. So a series is kind of a more overarching piece, and then the sequence is kind of like held inside of the series. So there is a difference between the two. The sequence is just the number pattern itself, and then the series is the sum of those numbers added together. Also for your reflection questions, you're going to have 2 that are going to ask you to write a series in Sigma notation. So this back page that you're looking at right now, it's going to be something like that. And then you're going to have to evaluate the following sums. So that would be something like what you saw on the first page of the practice. Next week's topic is going to be a fairly easy, hopefully easy for most of you, Algebra 2 review. So this is really the last kind of difficult pre-cal topic that you're going to have to do. So let's try to push through this and get this knocked out. You only have 2 more weeks of school left after this. So you've got this, you've got the Algebra 2 review next week, and then the week after that. So let's try to get this knocked out and finished. Let's finish strong. If you have any questions, please email your teacher. Thanks for watching, y'all, and have a great day.